Hello everyone. So welcome back to the Learn with Me Live second session. As you guys know, my name is Rahul and I'm an AWS community builder and machine learning and generative AI category. And I work as a machine learning engineer in freelance as in a tech company. And today we're gonna deal with a new topic called Demystifying the Metas Llama 3, the hands-on session with simple use case using Bedrock. As you guys know, right, and even if you follow me in LinkedIn, right, I've already published this as a blog, and I'll also attach the link for the blog in the description below. You can use the blog. Can you also use the code what I have written, and also add the GitHub link in the description box below, so you could just have a look at the code and have a look at. So I'm gonna just explain you what I've done so far with the Llama 3. Like I'm gonna just wake up with the performance of the Llama 3, right? But because as you guys know, Llama 3 is the newest large language model released by Meta, and which has the characteristics of Llama 2, and which also has the highest advanced characteristics than the Llama 2, right? And we're gonna call Llama 3 not from Hugging Face, and as you guys know, we do have a serverless platform called Bedrock, and through Amazon Bedrock we're gonna call Llama 3 and we're gonna implement it. But I'm not just gonna use only the API calling, and we're gonna have the entire architecture. Like we're gonna have the entire serverless event driven architecture. And as you guys know, if you have attended the deep learning.ai short course by Mike Chambers, he's the one, like you could able to see the same architecture what he has what I have done, say the same thing is he has said, right? So but he have used a simple more large language model over there, but I'm gonna delve into the Llama 3 and we're gonna talk a lot about Llama 3, right? So let's get into the session, right? So the session agenda is gonna be, we're gonna start with the Meta Llama 3 introduction, because as you guys know, we want to know about Llama 3. And this diagram, as you guys know, I've already added that in my LinkedIn post, but I'm going to explain you what is all about that. And we're going to talk about the data preparation strategy in Meta Llama 3 with the same Llama 3 stuff, all those things. And once we are done with Llama 3, we're going to get into the use case. We're going to delve into all what the use case is all about. Once it is done, we're going to start with the coding, and I'm going to explain the code what I've written in my VS Code, and I'm just going to give you a glimpse of what I've done, and I'm going to execute the code for you. Right, let's get into it. Right, so let's start with this thing and the architecture. Why? Because this is the first thing we need to know about it. Right, as you guys know, Llama 3 is the text-based large language model which has two different types of parameter sizes. One is all about the 8 billion parameter sizes, another one is all about the 70 billion parameter sizes. Right, so the parameter size is all about important. Why? Because the way the large language model got its name with the help of the parameter what is used to train the model. Now we do have the performance of SLM, which is the small language model. As you guys know, the Microsoft has released one of the SLM called as 5.3, where from the 5.1, and as you guys know, in my latest what can I say, newsletter, I'll also give the link for the newsletter what I write in LinkedIn in the description box below. Just have a look. Why? Because I don't even have a look at the what can I say, I just try to take the basics behind the LLM research, right? So if you see, if it is 5.3, then I'll try to take 5.1. So the textbooks, or all you need is the model, the paper, the name of the paper which is released, right? So why? Because as you guys know, right, whenever we are entering into the research phase, we need to know about the basic understanding about what the research comes in from. So that's why, right, whenever we are getting into the LLM or any new LLM in the point of view, I want to know about its its previous architecture, how it has been evolved into the new architecture. So that's the case. So as I said, that Llama 3 is the text-based large language model which is gonna train on both two different types of parameter sizes. One is all about the 8 billion parameter size, and another one is all about 70 billion parameter size. And as you guys know, it's a decoder only architecture, because only if it is going to be a decoder only architecture, it's going to generate the text for you. And there are several key improvements from the Llama 2. If you say that Llama 3 uses the tokenizer with a vocabulary count of 128,000 of tokens, that encodes the language much more efficiently. And moreover, rather than from the Llama 2, you could able to see the Llama 3 has adopted the GQA attention, like the grouped query attention on both the parameter sizes, say the 8 billion as well as the 70 billion parameter sizes. And moreover, Llama 3 models are trained on the sequence of 8,192 tokens using the mask to ensure that there is a self-attention which does not cross the document boundaries what has been given to the Llama 3. So this is the base, right? As you want to know, Llama 3 is a text-based large language model with two different types of parameter sizes. It's a decoder base, and make sure that there is some difference from Llama 2 to Llama 3, right? That's the thing we need to want to know about it. So what are the data stuffs behind the Llama 3? Well, because as you guys know, since it is a large language model, what is the, what may I say, the data used to train the model, right? The first thing is all about almost from the publicly available sources, 15 T or teras of tokens are being taken, and moreover, it is 7 times larger than used in Llama 2 and 4 times more code needed than the Llama 2. Okay, take a note, right? Whenever you learn, right, this is going to be the comparison from the Llama 2 to Llama 3. Why? Because comparing Llama 3 with Llama 2, we need 7 times larger data, and moreover, we need to have 4 times more code in terms of Llama 3 than the Llama 2. And moreover, you could able to see Llama 3 has an upcoming feature of the multilingual use cases. Why? Because this is going to be the base, right? It consists of 5% of Llama 3 pre-training data sets, which has the high quality of non-English data from over 30 languages. And when I started to learn the Llama 3 release in the Meta's blog, right, I could able to see there are there are 4 different types of things we could able to get into over this. The first thing is, as I already said, the grouped query attention. The second thing is all about the multilingual use cases. The third thing is all about the data filtering pipeline. So how the data has been filtered before giving the data to the Llama 3. So the first thing is all about the heuristic filters, what we get into the mind. So that's going to be given inside the Llama 3. And second thing is all about the NSFW filters, as you guys know, and the semantic deduplication approach. And coming to the text classification point of view. To train the text classification point of view for Llama 3, the researchers of Meta use Llama 2 to generate the data. So it's going to be a very interesting case. Why? Because they are using the pre-version of the newest largest language model to train the model train the newest largest language model. So that's the case, right? They have used Llama 2 to Llama 3 to train the data. So a more sophisticated here in the case they have used for text classification point of view. So these are all the data stuffs behind it. As you guys know, whenever you need to know about those things, whenever a large language model has been created, there are 3 different steps you need to know about it. So how the pre-training has been done, and how the supervised fine-tuning has been done, maybe an instruction fine-tuning or count out of the fine-tuning has been done. Thirdly, with the RLHF, that is, as you guys know, the reinforcement learning human feedback, how the reinforcement learning approach has been used to judge the performance of the text or the output generated by the large language model. So coming up to the pre-training part, right, in terms of Llama 3, so there are series of detailed scaling laws for which you can able to use to downstream the benchmark evaluation. So there are some of the steps you guys want to know. I've written like the basic overview about it, right? You have to select the optimal data mix, make the informed decision, and predict the performance of the largest model on the key task. And as you guys know, whenever you enter into the LLM architecture, there might be a parallelization techniques where we need to know about how the data, how the tasks are performed parallelly whenever we are importing the question or the query to the model. So the first thing, the data parallelization. The second thing is going to be the model parallelization, and third thing is going to be the pipeline parallelization. So just have a quick overview about it, because I'm not getting much deeper into what are all those steps, right? How data parallelization will work, how model parallelization will work, or how pipeline parallelization will work. I'm not getting much deeper into it, because I just want to give you the overview about it. And once it is done, right, and even I'm gonna plan for a series of learning LLM, right, through what are the steps needed and what are all the disadvantages, and how each and every step, like how the decoder only architecture works, how the encoder only architecture works, how encoder and decoder. And as you guys know, right, in the previous session we talked about the transformer architecture, which is the base architecture, right? You could able to see for the generative AI stuff or the LLM architecture, the transformer one was the base architecture, the foundational one which provides you the base for each and every LLMs right now, which is on working on it, right? The next case, let's talk about the instruction fine-tuning. As you guys know, as I told, right, it has the supervised fine-tuning, and when it's coming to the reject sampling too. Then coming to the reinforcement learning human feedback, they use two different approaches. Because each, if you see over, they might be using any one approaches, but in Llama 3 they have used two different approaches. One is all about the proximal policy optimization, and second thing is all about the direct preference optimization, which has been abbreviated as PPO and DPO, stuff like that. So just to know about, right, just adding some reinforcement learning feedback to the output generated by the LLM to make sure that yes, it works correctly or not, or anything else. Right, so now let's talk about what TouchTune all about. Why? Because when I started to learn Llama 3 release, they could able to see Llama 3 is available with TouchTune. Then I looked into what TouchTune is all about. TouchTune is nothing but the PyTorch native library for easily fine-tuning your model and experimenting with the LLMs. And to be more precise, this Llama 3 is now available in Hugging Face. You can just use the Hugging Face transformers to call the Llama 3 model, and is also available in weights and biases, user array and execute torch, and it is also available in your cloud thing, like it using Amazon Bedrock or any other cloud, right? I'm just specifying only Amazon Bedrock. Now, what are the responsibility measures they have used? So I'm not going to talk much more about the responsibility measures now. Why? Because I could able to see the advancement of responsibility measures are right now upcoming, right? And we could able to see they have used the system level approach, and we could able to see the diagram over here, what I mentioned, what I've given, and this diagram is taken from the Meta's blog. So like I've taken that from the Meta's blog, right? And what are the other security measures? Like they have used three different types of security measures. The first thing is all about the Llama Guard 2, right, which is an abbreviated version, which is the what can I say, the advanced version of Llama Guard 1 and the CyberSec Eval 2. So you could be able to see the names of it, right? And I don't want to go much deeper into it, but because I'm not a part of a security person, but right now I'm also learning into it, but because recently I've learned a paper called as Smart, right? I've just literally, what can I say, how the manual, the difference between the manual or red teaming versus the automatic red teaming works in the case of do it. Right, I could able to see how the automatic red teaming provides the best output and how manual red teaming provides the best output. What are the cost difference to it? I'm learning it right now, so I'm not the person who wants to tell about much deeper inside about what are the security measures there. But whenever you go, right, so whenever you see a new LLM has been released, they might be using lot of responsibility measures that they should not go behind the topic, and it should be it should be constructed in such a way that it should be able to solve the problem which is being given to it. And there might be a lot of issues that they should be working towards it. Right. So this is all about the, what can I say? This is all about the Llama 3 model. And to be more precise, I want to rephrase it one more time, or I want to say it one more time, that Llama 3 is a new text-based large language model which consists of two different types of parameter sizes. One is all about 8 billion, another one is all about 70 billion. Now let's have a look like how I'm gonna use, right, how Mike Chambers have used the serverless driven architecture. So what we are going to do is nothing but we're going to create a summarized model. That summarized thing is going to take the meeting transcripts as an input and is going to provide the summarized meeting outputs, summarized meeting transcripts, right? But this thing is not going to upload something like, I'm not going to add everything from my desktop or something, right? I'm not going to do anything manually. This is going to be done with the help of event notifications. Why? Because we're going to do something called, whenever anything added to the S3 bucket, that S3 bucket event should automatically call those sophisticated things and need to execute the output for it. And moreover, this is serverless. We are not creating any kind of servers over here. This is going to be an entirely serverless driven architecture. I have drawn the architecture over here. This is the same architecture used in the course. If you don't if you haven't enrolled in the course, I'll just push you the link below in the description. Just have a look at the course and start learning the course behind it, right? And let's start. I'm gonna go much deeper. Why? Because this is what we need to talk about today, and I'm gonna show you the output, what app returned for this thing. The first thing, right, we might have the meeting audio file format might be in MP3 format, right? So for this case, right, before entering into the architecture, for this case, you might have also seen that in the thumbnail, right? We're gonna have the interview between the Mantra Bedi and Dhoni, right? So you could able to see that thing, right? I've also like you might be able to see that thing, and I also play that what can I say, the meeting things, right? I'm just taking the meeting thing from from the website. So that's the meeting, and that's where like how short and sweet where the meeting can be transcribed. That's why it can also able to generate a large number of tokens based on the parameters what you're gonna pass. But I could able to see Llama 3 can able to produce a short and sweet transcription, short and sweet summary, so that we can able to understand what the meeting is all about, right? So that's the thing, right? I do have the meeting audio file format. Once I do have the meeting audio file format, I'm gonna push that back to the Amazon S3. So once I upload this audio file into the Amazon S3, I'm gonna create an S3 event notification through this Amazon S3. What is that? Whenever I upload a file inside the S3 bucket, and another Lambda function should be called, where that Lambda function should invoke the transcribe, Amazon transcribe. As you know, Amazon transcribe is the automatic speech recognition service, which when we give you the audio, it recognizes the audio and provides us the text as the input, right? So it just takes the meeting audio format from the S3 bucket, transcribes it, and put it back to the same S3 bucket. So now the transcribe part is done, but we need to summarize the part. So now we do have another S3 event notification to the same S3 bucket, says that when when the transcribe file from the Amazon transcribe pushes directly into the Amazon S3, this Lambda function should get called, where this Lambda function will summarize the transcription which has been given to it with the help of Amazon Bedrock, where this Lambda function will call the Amazon Bedrock, and with the help of Amazon Bedrock, we're going to call the Metas Llama 3 to summarize the transcription. So it's going to have the body of it. As you guys know, whenever you are invoking a model, you are supposed to know the body of the model. That is very, very important, right? You need to know about the body of the model. So once it is done, once the summarize is done, I'm going to store the summarized thing into the same S3 bucket. So everything happens inside the same S3 bucket. So we're going to work with some of the nuances on the S3 event notification and stuff like that. So let's have a look at this in this code. I'm gonna run through the code, and this is the code what I've written, right? So before going to the event driven architecture, right, I'm gonna go the two important files. First thing is all about, right, how the transcribe audio file is done, and how the transcribe audio file is done, and how the summarized audio file is done. Why? Because not a simple case. Why? Because we this is the thing what I've written in both both of the lambda functions. So this is all about the transcribe audio file. You could able to see, right, I'm just created a transcribe client, say with the help of the transcribe client. So with the transcribe client, I've created the transcription job. So once the transcription job is done, and to be more precise, I've created the settings as to make sure to show the labels of the speaker. So either the sentence has been spoken by this person or that person, right? But you can't able to identify the speaker, but you can able to identify the speaker as speaker 0 and speaker 1. With the help of that, we can able to reframe it, who's the speaker 0 or who's the speaker 1. And I've given that as a maximum speakers as 2, and you could able to see this is audio file. I'll show you once both the code is done, and once I've explained both the code, I'll show you what is the audio file. So it is the conversation between the Mandira Bedi and Mahendra Singh Dhoni. You could be able to have a look at it. And once it is done, right, so I'm gonna, I'm gonna take the transcription job, transcribe file which is being stored inside the same S3 bucket. I'm gonna work in the case, right, I'm gonna split the transcription based on the dialogues what has been spoken by both the persons here, Dhoni and Mandira Bedi. What are all the the words spoken by Dhoni? What are the words spoken by Mandira Bedi is very, very important, right? So that's the stuff what I've done in the entire. So that's going to be the simple logic, the same logic which was employed that in deeplearning.ai short course by Mike Chambers. I've written the same thing. So this is all about transcription. Then I go back to the summarizing point, and I've used the Bedrock runtime client to call the model, right? So here's the prompt template. What I've given is nothing but I need to summarize the conversation between Dhoni and interviewer, and you could able to see the transcript of the conversations between so I've given the transcript over here and below. and you could able to see the summary should concisely provide all the key points of the conversation, where and you have to write the JSON output and nothing more. Yes, the JSON output, stuff like that. And this is gonna be the body of the Llama 3 model. As I said, there are two different versions. One is 8 billion and the one is 70 billion. I've used 8 billion but because I could able to see the output codes for it. And if it's going to be a complex use case, you could be able to use any of the models what is available in the Bedrock, right? So I've just used both. And I've given the maximum generation length as 1000 tokens and with the temperature of 0.5 and top underscore p parameters are 0.9. So as you guys know, temperature parameter in LLM is nothing but it just determines the randomness in the output generated by the LLM, and top underscore p provides you the proportion, like the probability of the next token which is going to be generated based on the previous token which has already been generated. So that's the parameter. So 90% of the token is going to be yes, this is going to be the next token what is going to be predicted based on the previous token which has been given to it, right? So this is all about the stuff, right? And I have created a lot of things, right? I don't want to talk much deeper into it, but because I've created two lambda functions. That lambda function is present inside this lambda code inside the object transcript and transcript summary. What I've said right now, it has been available. So I'll just walk you through this thing, but because I've created two objects to make sure what are all the operations there in S3, what are the operations there in Lambda. You could able to have a look at the operations in the GitHub file of what I've already uploaded that in my in my description. You can just have a look at the GitHub repo and you can just have a look. Right, so let's go into it. I have the bucket name, and you could able to check. This is my Amazon console, and you could able to see. You could able to see there is a bucket called as transcribe even1, and that's the bucket what I've given over there. And I'm gonna add an environment variable based on the bucket name, and I'm gonna deploy the lambda function with the name as the lambda transcribe. I haven't implemented it. I want to implement it real time. I'm just waiting for it. And here, first of all, when we are adding the audio.mp3 file, right? So I've added the rules of physics. Why? Because inside the same bucket we are adding two different things. So first thing, we are adding the mp3 file, and once the mp3 file is added, the transcribe will do the job and get back to the same S3 bucket and uploads the JSON file. So that's why to differentiate the invocation of the lambda functions, I've added the suffix for each and every lambda function what I'm gonna have. So for this lambda function, the suffix is gonna be .mp3, and once it is done, I'm gonna add a lambda trigger for this, for this bucket name. This is gonna be the trigger, like the input trigger is gonna be the bucket name. And once it is done, I'm gonna upload the lambda, and I'm gonna just check for this one. So it takes time, but because the transcribe doesn't take much time, but I'm gonna uploaded something, right? The next stuff. This is going to be the first part of the architecture, and this is going to be the second part of the architecture. The second part of architecture is all about the lambda code, which does the summarization point of view. So I've deployed the lambda code and the rule suffix as the .json file. Once it is done, I'm gonna add the lambda trigger, and I'm gonna wait for a while. I'm gonna use the time .sleep of 100. So just wait for a while, because once the transcription want to store it back, so I'm just putting a small bit of time so that it takes much more sufficient time to get all those get invoked. And once it is done, I'm gonna list the objects. You could able to see the difference in the objects. And once it's done, I'm gonna download the results.json, which is gonna be, I already have the results.json in nearby because I've already implemented, but I'll also show you how it works. Right, and before implementing this, I just want you to show you what the audio is all about, right? So this is for the audio. I want you to listen for the first 10 to 15 seconds. So just get to know about what the conversation is all about, just to give you the intro about what the conversation is all about. And here we go.
There are people all around, there are cars parked all around, there are people on the street. You look ahead, there are thousands of people. You look behind, there's thousands of people. And everybody had a smile on their face. None of them are sitting in the car. All of them are outside.
Here's the thing, I'm sure you've noticed this, that every time you come to an event, there's a...
So yes, so this is all about, and I haven't taken the entire meeting. I've just taken only the main phrase of the meeting, which consists of almost 11 minutes and 55 seconds, right? So we're gonna summarize this. What Tony said, what is the conversation is all about, right? We're gonna go ahead and do into it. So let's start implementing it. I'm gonna just start running this thing. So let's wait. So I've already done a bit ago, right? Before starting this video, I already implemented it, but I want to do it. So what happens? There is already a function, and everything works good, right? So let's wait for a while until everything does it, and we need to wait for a while until the everything starts into it. So now could able to see, and I'm gonna go back to the what may I say, console, right? Let's have a look inside I'm inside my console. I could able to see the functions, and I'm gonna, what can I say, revert it back. You could able to see there are two different functions created, as I say, the lambda summarize and lambda transcribe, and you could able to see, yes. So once it is done, because I've just, what can I say, done some kind of fast method in my things, and I've implemented it. So what happens in this case, right? You could able to check once the object is being uploaded inside, and once the thing is done inside, and you could able to see there is a results.json file, right? I already have this results.json file here at my I say my console, and you could able to see, right, this is gonna be the summary of it. Right, I'm just writing it, and which it's in the JSON file, so it will give you some error when I put it into it. So you could able to see Dhoni talked about the cricketing career, his feelings being referred as a legend, and his views on luck. He shared two priceless moments in the cricketing career, one after the 2007 T20 World Cup and other during the 2011 World Cup. He also talked about the daughter Ziva and the priceless moment when she recognized him for the first time. And he advised youngsters to focus on their core, and everything else will take care of it. So you could able to see like just the 4 lines. This is what Dhoni talked about, right? I could also able to remember the remember the meeting, right, when I watched this. So he just talks about like everyone was standing when we won the World Cup, when we won the first 2007 T20 World Cup, then when goes 2011 World Cup when he hits the last 6, right? So that's the thing he was talking, right? So you could able to see like and concise summary has been created with the help of the maximum generation, right? I'm going to create only 1,000 tokens, so that's going to be the part, right? You can also generate a lot of tokens, but from this thing I can able to understand. So even, right, this is going to be the simple use case what you create through Bedrock and create through those things. And moreover here, this thing is everything comes from the audio file, and you could able to also check how the transcribe file will look like into it. So this is gonna be the transcript.json before applying. That's a very important stuff. Before applying the logic what I've added, right? Before applying the logic what I've added, this is gonna be the transcribe file. You could able to have a look, like it just simply says there are people all around, there are calls. It just gives us the transcribe part, but it doesn't explain who spoke what things. But once it's done, everything has been done. After this, after the logic what I've implemented, here comes the beauty, right? So it just cries in the correct way. Yes, it correctly understands what is the thing talked by whom, and all those stuff behind to it, right? So this is the stuff behind, guys, and I wanted to show you. And you could also take the architecture, why? Because I've drawn the architecture here, and like the architecture is available. You can also have a look at the architecture, and yes, that's it, guys. So thank you for listening to the Learn With Me session 2. Right? I think so. Hope you have learned it, and I've given all the links in the description box. Use the link, use the description links, and just have a look at the blog. Just have a look at the code what I've written, and implement with the new model which is coming, right? Which has been there. Or if you want to experience with the other models what you have, you can also have a look at this thing. And if you haven't followed me in LinkedIn, like you can also follow me in LinkedIn. My name is Rahul Gopal. If you just type, you could be able to see my face. Right now, this is not my face, but because I have changed my profile pic. But somewhat you can able to recognize me. Yes, you can able to recognize me. In the bio itself, I represent that as an AWS community builder and ML engine AI. And if you want to have something, if you have any questions, you can also look at me in LinkedIn. You can ask me the questions, and if you want to ask any questions in mail, you can also follow that to the mail. And if you have any comments, just leave a comment below in the video, or if you want to interact with me, you can also connect with me in LinkedIn too. And as I said, I've started the newsletter called the same name, the Learn With Me newsletter. So totally right now I've covered almost 15, I'm not sure 15, I've covered almost 10 to 15 research papers. And if you haven't joined it, there's a link. I'll also post this link in the section in the description box below. Use the link and start enrolling it. Just start learning with me so that you can also be the part of the LLM. What may I say? I could say the LLM cycle, production cycle right now. What is happening towards it, right? All the best. Let's see in the next video, right? Let's see in the next Learn with Me Live, or in the next video what I'm gonna push it into the stack. So until then, happy AI and happy coding. Whatever I follow in my newsletter, I've just said. So happy AI and happy coding. Thank you.